So hello guys, today we'll be talking about Arduino UNO Q. So what is Arduino UNO Q? The Arduino UNO Q is different from a typical Arduino. It's actually a 2-processor in one board. So there's a Qualcomm Dragonwing QRB2210 running full Linux and an STM32U585 handling real-time microcontroller tasks. So just like a classic Arduino. You can also think of it as a small Linux computer and a real-time Arduino sketchboard. So this is fused together and able to talk to each other. So in this section, we'll get the board set up and understand how these two brains communicate before we build anything complex. So the next step will be installing Arduino Applab. So to work with Arduino Uno, we'll use the Arduino Applab. So this is a separate development environment from a classic Arduino IDE built specifically for this dual brain workflow. So to install this in our host PC, first you need to go to the official Arduino Applab download page and choose your own OS installer. So after downloading, run the installer and follow the setup wizard and then launch the Applab once installed. So now let's continue to the UNO Q. Plug it into your PC using a USB-C cable. There will be no external dongle needed for this workflow, since we're connecting straight to the host computer rather than running it as a standalone desktop. So after plugging in your Arduino UNO Q, open Arduino Applab and choose your board. After choosing your board, go to board configuration where you can type your board name. Here's mine is Arduino Azrael Q, which is tailored to my preferences, but you can choose whatever you want. So after that, you will go to network setup where you can choose to connect your own Wi-Fi. Here's mine, and just type your password. So this is necessary for further installation. So after typing in your password, select confirm, then wait for it to load. Then here you will be prompted to your Linux credentials, so you will have to choose your own password for this board. So be very careful in choosing a password, and always remember, I always forget my password. Okay. So type in your password. Then click confirm. Then you will be prompted again for looking for updates. So this is highly recommended for new user to install updates so that you can have features that will be useful in future projects. So just click install and wait. So this update can actually take some time, so I recommend wiring your hardware first while this is installing, so that you won't waste time. So, and just wait for it to fully download the update. So after that's done, you need to restart Applab. So just click restart Applab. After restarting Applab, you can see here you have different examples to choose from. You have a Cloud AI Assistant, Bedtime Storyteller, you also have a Color Your LED, blink LED, and and the weather broadcast on LED matrix, and many more. Also, you have a bricks, which is a modular software building blocks that allows you to add complex pre-built functionalities to your projects with just a few lines of Python. For building your project, first is you need to check your IP address shown here and get the IP address of your iNet. So take note of this IP address because you will use it later on this project. So now let's connect from our own computer terminal. So open your board terminal, then just type in this command, which is the SSH Arduino at your board name. In my case, it'll be Arduino-Azrael-Q .local. So this will be your command, and it will be prompt to enter your password. So just wait. So if ever the host name doesn't resolve, you'll have no problem for that. You just use the IP directly instead. So this we have here a prompt to say, just say yes in that, then just type in your password. Then that's it, and it's done. So for the next step will be updating the system. So first thing, on any fresh Linux, install update the package list and upgrades what's already there. So if you have a new board, first thing you would do is type this command, the sudo apt update. Then it will ask for your password. Just type in your password. Then after that's done, just type in sudo just type in sudo apt upgrade -y and press enter. So wait for it. So make sure that you have internet access for this, and the board also is connected to a Wi-Fi that has internet access for this to work. So this will take a lot of time, so just wait for. So you can check here if so mine is already up to date and I have no services needs to install. So after that, next step would be installing the Mosquitto. So in order to install the Mosquitto, just type in this command, sudo apt install Mosquitto -client clients-y, then press enter. Again, you'll be prompted to type in your password. Just type in your password, wait for it to install. Again, this will take a lot of time, so be patient. So you will only do this once if you have a fresh board, but if you are working for a future project, you won't have to do this again. So after that, you would need to type sudo systemctl enable Mosquitto. So this will enable your Mosquitto in order to use the software. So after that done, type sudo systemctl start Mosquitto. So this will start your Mosquitto. Then type in sudo systemctl status Mosquitto. So with this command, you can check your status of your Mosquitto. As you can see here, it is active and running, and you can also see that it is enabled. The preset is enabled. So this next command will be the sudo nano /etc/ mosquito /conf.d /local.conf. So by default, Mosquitto only listen on localhost, meaning only board itself can talk to it. So we need to open it up so our sensor and actuator board can reach it too. So just type in this listener 18830.0.0, then press Ctrl O, or just press enter. Then type in allow anonymous true. So if that's done, just press in Ctrl O, then enter, then Ctrl X, so that will write it. So you need to restart and verify. So next will be restarting your Mosquitto. So sudo systemctl restart Mosquitto, then check if it's listening. So sudo ss sudo ss dash tlnp, that's supposed to be one more space, and grab 1883. So as you can see, this line right here, the 0.0.0.0 colon 1883, that's our confirmation if the board if it's open to the whole network, so not just the board. So let's have a quick MQTT test. So let's prove that the broker is actually working before moving on. So just type in mosquitto dash or underscore sub dash h localhost dash t quotation mark test slash topic quotation mark end, literal the end symbol, then press enter, and as you can see, the output will be 24332. Now the next will be typing in this mosquitto underscore sub dash h localhost dash t quotation mark test slash topic quotation mark hello. So it should print out hello. Oh, unknown option. Also, that's supposed to be a pop, not sub. So that's that. Let's just type it again. Type in mosquitto. This time it should be pub, so underscore pub dash h localhost dash t quotation mark test slash topic quotation mark dash m quotation mark hello. So as you can see, it prints hello. So that's my Shopee. That's fine. So there it is. Hello printed right there. So for this section, as you can see, I just copy and pasted this whole command. So you can copy and paste it from the documentation we have. So this is to install the Node-RED. To install the Node-RED, just type paste that command, type your password, then wait for it to install. This also can take a lot of time for first-time user. As you can see here, my version will be 22.23.1. The NPM is 10.9.8. Then type in this settings file command. You just copy what's written here. So just type in those home-arduino node-thread-setting.js. Then here you can choose whether you usage data or no. I choose do not send my usage data, of course. And do you want to set up user security? I choose yes. Type in your username. Whatever you choose, it's okay. Type in Azrael, then my password. So again, be very careful for your password. Don't forget it. Just me, like me. Oh, sorry. Okay, type in my password, then choose full access, then choose no for another user. Do you want to enable that? Yes, I would like to. And yes, I would like to manually commit changes. I would like not to have auto. Wait. I choose auto. Sorry. So you can choose here the theme for your editor. So and allow function nodes to the extension. So that's it. That's done. So you have installed Node-RED and you have installed Mosquitto. So we are almost done. Next would be starting your Node-RED. So in order to start Node-RED, just type in this bash command, this node-red-start, and as you can see, pointed browser at 1.17.17.0.1, but that's not where you can find your. Remember the IP address that we got earlier when we the very first command. Do you remember your IP address? So if you remember your IP address, next thing you would do is open your own browser, which is here Bing. Then just type in your IP address :1880 to open your Node-RED. So sometimes it's slow to it depends on the connection of your Wi-Fi. So as you can see here, you're prompted to type in your username that you created earlier. Remember your username and also your password. So this is if you're using Node-RED for the first time, you will have this so that you will be familiarized. You can familiarize Node-RED. Just press next and then you're all set, and then close. You can either create a project or you have to clone your repository, but mine I don't have to do that right now, so I would have to pick not right now. First thing is wait. So I like dark mode much better. So just So now let's start to actually building the automation flow in Node-RED. So to build the actual logic, we need 3 inputs. So just type in the MQTT in 3 times. Then add your function and 1 output. So the function will be the decision maker. So in the first MQTT in Node, in the right side palette, just double click the node, then add a server. Mine will be you can choose whatever you want, but mine will be localhost and the port is 1883. So that will be used in all the MQTT nodes. Then just type in the topic. It will be home, room, light, because this will be a node for the light sensor. So just name it light sensor. Then press done. Do that to the other nodes. So just pick the localhost 1883 and just type in the home room /motion. Now this will be your motion sensor. So press done. MQTT localhost. Again, home room /the sound, because this will be the sound sensor. So now we have here the sound sensor. Now we need to actually make decision for this automation. So just paste in the command that we have in our documentation at Applab store. So you can either tailor it to your preferences, get any logic that you want. So here's mine. Just press done. And lastly, the output of your automation. So same thing, you get to pick the localhost 1883. Then choose the topic will be the homeroom light set, and I would name it relay, because this our actuator will be a relay. So just wire this input nodes into the function, and then wire your function into your output node. Then click deploy. So that's it. Let's say successfully deployed. So I have some unused configuration, but that would be unnecessary, so I'll just use this. And again, this is my command or code. And that's it for this building the automation flow. So in this project, we got 3 boards, and each one runs its own sketch. 2 are sensor nodes that publish data, and 1 is an actuator node that listens for commands. So let's go through each one and break down exactly what the code is doing. So first here we have the first sketch for the XIAO ESP32C3, which handle the PIR and the BH150 sensor. So the first board has one job: it reads motion and light level, and this publish both to our MQTT broker. So we have here, right at the top, we set our Wi-Fi credential, and also the MQTT broker IP address. So this MQTT broker, so this is the UNO Q actual IP address. So replace this with your actual IP address, because each has different IP address, because we use a different Wi-Fi. Also in Wi-Fi credential, change your Wi-Fi name and your Wi-Fi password so that it would connect. As you can see here, we have a void setup function that has a delay of 10. So this function connects us to the Wi-Fi. So it just loops, printing a dot every half a second until the connection succeeds. As you can see here, half a second. Then checks if the Wi-Fi is connected. It also prints the XIAO IP address. So next would be the void reconnect MQTT, which is a function that connects us to the Wi-Fi. So the next would be the void reconnect MQTT function. So this function handles connecting to the broker, and also reconnecting automatically if the connection even drops. So notice it gives this board its own unique client ID, the XIAO sensor node 1, so that the broker can tell it apart from other devices. So it prints if the MQTT is connected, and it also prints if it failed. So next would be the void setup function. So in this setup, we start serial for debugging and set the PIR pin as an input. So this is the serial for debugging, and we set the pin mode for the PIR as input, and we initialize the I2C bus for the BH1750. Then connect to Wi-Fi and set our broker address. So you can see here, set up Wi-Fi and then connect to our broker address. Void loop function is the actual work. So every single cycle, we read the PIR pin high means motion, and we read the BH1750 for the current light level in lux. So after that, we publish both values, motion to one topic and light to another. So we print the same info to serial so we can watch it live for testing, then 1 second delay before doing it all again. So the whole sensor node will have to read, publish, and repeat. Next would be the code for XIAO ESP32C3 that handles the sound sensor. So same thing with your the previous code. You have to change your Wi-Fi credential, which is the Wi-Fi name, Wi-Fi password, and the Wi-Fi then the MQTT broker. So this code is for the sound sensor that detects clap. As you can see here, we have the ball arm that equals to true. So true means ready to detect a new clap. This also have its own void setup Wi-Fi to see if it's connecting to the Wi-Fi, and also a void reconnect MQTT for connecting to the MQTT broker. So
the void setup would be set the pin mode to input, and we also call the function setup Wi-Fi for it to connect. So the logic of this code will detect a clap. So whenever the sensor detected the clap, then it will trigger the LED to turn on. It would be the code for your actuator. Here we use a different board, which is the ESP32 dev module. Will have the same Wi-Fi credential. Just edit this, your Wi-Fi name, Wi-Fi password, and the IP. Also make sure that the tree code will have a subtopic that corresponds to the topic set in their node red. So as you can see here that it assigned the pin of the relay and assigned the pin of the OLED. So the first function would be void update OLED. So this function redraws the OLED screen with 3 lines, a title, a current connection status, and whether the LED is on or off. So we call this function anytime sometimes changes, so the screen always reflects the LED. The function void set relay. So this is the function that actually flips the physical relay. So it takes in a string either 1 or 0, then converts that to true or false and writes high or low to the relay pin accordingly, then it updates the OLED match. Next would be the void callback. So this function is the heart of the whole sketch. So this function runs automatically, and anytime a new MQTT message arrives on the topic we're subscribed to, it converts the raw incoming bytes into a readable string, prints it for debugging, then hands it straight to the set relay to act on. So this is what gets and receives the message coming from your node red. So it also have the void reconnect MQTT, same reconnect pattern as our sensor node, but this one have a key difference. So right after connecting, it calls client subscribe on our command topic. Here, it's client subscribe. Without this line, we connect to the broker just fine, but we're never actually receiving anything. So in the void setup, we force the relay off immediately. So this is a safety feature. And also this connects Wi-Fi and tell the MQTT client which function to run. So whenever a message comes in, so that is our callback. And notice how this void loop is simple compared to our sensor, because there is no reading, no publishing, just client loops, which is what actually checks for incoming messages behind the scene and triggers our callback function the instant one arrives. So to summarize the whole system, our 2 sensor nodes are constantly reading and publishing our node red's flow, sitting in the UNO Q, is constantly listening to all 3 sensor topics and deciding what LED should do, and our actuator node is just sitting quietly, waiting for the moment the node red publish a decision. So this board callbacks function fires instantly and the relay flips. So these 3 small sketches, each one clear job working together over MQTT to make this whole automation loop happens. So the next thing I want you to do is to listen to this video that is created by my partner, so that you will learn how to wire our actuator node and the 2 sensor node. So this is also explain what components is used and how to use it and what's their functions.
So let's walk through how to wire the components by following this diagram. This sensor detects movement by sensing changes in infrared radiation from people or objects. This one measures ambient light brightness. It is designed to act like the human eye by detecting light and outputting the data directly in lock. Next is the ESP32C3, which serves as the brain of our project. It processes data from the sensors and controls the entire system. So this is the output wiring. I cut the video to make finishing this part easier. Next is the wiring of sound detector to ESP32. So this is a simple device that detects sound. It simply presents a microphone. Once both sensors are connected, compare your setup with the wiring diagram to ensure every connection matches. And last but not the least, the OLED and relay to ESP32 development board. This one displays the status of our sensors, if it's working or not. This is a small switch that lets our microcontroller safely turn high-powered devices. That's it! Our hardware setup is now complete.
So in this part, I will show you the whole system. As you can see here, this is connected and wired. Also have its own power source. So first, I will explain to you the components that is used here. So we have here the ESP32 dev kit, the actuator node, and the relay module that controls the LED. And we also have the two ESP-C3 for sound and the C3 for light, and the sound detector module, and the light level module, and the PAR module. So this system, we have a hierarchy of command. The first will be the sound detector. So the sound detector module is in the top of the hierarchy of all the sensor. So if it detects a clap, it will turn on the light regardless of whatever the status of the other sensor. So to turn it off, you need to clap twice again. So these all display the status of the LED and if it's connected. And also this sound detector module is not yet calibrated, so you have to calibrate it first because it detects the background noise, or you have to use a better sound detector module, which is also available at greatlabs.com. And also we have another sensor module, which is the light intensity module. So this module detects the threshold of light intensity. So if it detects the 50 below threshold, then it will turn on the LED, and only to turn it off you need to clap and use the sound detector module, because that's in the top of the hierarchy of our sensor. Also we have a PIR module sensor. This can actually be used to control another relay, so just add another relay for this system.
So this project shows that a complete local cloud-free automation system can run entirely on a single Arduino UNO Q. So we took it from a fresh unconfigured board all the way to a working smart home loop with two XIAO ESP32C3 sensor nodes reading motion, light, and sound. An ESP32 actuator node controlling a relay and auto display, and the UNO Q itself hosting both the MQTT broker and the node-read automation logic that ties it all together. So the result, no cloud subscription, no internet dependency for the system to run, and a fully local, editable, and extensible foundation ready for more sensors, more automation rules, or a bigger dashboard down the line.